Hello everyone. In this video we're going to be solving a system of equations. We have 4x squared plus 9y squared equals 10xy plus 12 and 2x plus 3y is equal to 2xy. And we're going to be solving for x and y values. I don't know how many different methods we can use. Let's go ahead and explore. So I don't know if you noticed, but 4x squared is 2x times 2x, and 3y times 3y is 9y squared. In other words, these expressions right here are the squares of 2x and 3y, which is a good thing. And that kind of tells me, I think I should start by squaring both sides here. Don't you think? So let's go ahead and do this. Square both sides. So we can kind of, sometimes they write it that way, but let's write it this way. Okay, we'll square both sides, and that'll give us 4x squared plus 9y squared, kind of like a squared plus b squared plus 2ab. And 2ab is going to give us 2x times 3y is 6xy. Double that, you get 12xy. And that is equal to 4x squared y squared. Now you might be thinking, like, how is this helpful? Well, if you look at the first equation, you realize that 4x squared plus 9y squared can be written as this. So we can go ahead and use substitution. Let's go ahead and do that. Replace 4x squared plus 9y squared with 10xy plus 12. And then plus 12xy equals 4x squared y squared. Does this look better? Now let's go ahead and do this. These two are like terms. Let's go ahead and add them. 10 plus 12 is 22xy plus 12 is equal to 4x squared y squared. Great. Now, notice that this is a quadratic equation. It's quadratic in xy. So if you set xy equal to p, by the way, I use p for product and usually s for sum. Notice that we have both of these. Well, at least we have the product, right? So this equation turns into 4p squared. I want to write the quadratic term first, equals 22p plus 12. Obviously, we can divide everything by 2. 2p squared equals 11p plus 6. Nice. Let's make it nicer. Put everything on the same side. Subtract and subtract. Now we got a quadratic equation in standard form. Nice. So let's go ahead and solve this. You can try different methods. One of the methods that I really like, and by the way, that's something I learned from my students, which is interesting. You sometimes learn from them, actually a lot of things. And I can show you that. That's one way to approach it. And the other approach would be the quadratic formula. Quadratic formula is kind of like guaranteed. You can just solve it. With the X method, you need to do more work, but it's actually worth it, okay? So let's go ahead and try the X method here for illustration purposes. And here's how it works. You take the coefficient of p squared, and you take the constant term. If it's a minus, you have to take the minus. And their product is going to be negative 12. So you make a big giant X, okay? That's why it's called X method. And then you go ahead and put the product here. The product is negative 12. And the sum is given, and this should remind you, what's it called? Vieta's formulas, and the sum should go here. So again, this is the product, and this is the sum, which means you're looking for two numbers whose product is negative 12 and whose sum is negative 11. And those numbers are actually really easy to find. If you think about it, you're going to realize, okay, those numbers are negative 12 and positive 1 because they satisfy the product and the sum. Make sense? If the product was positive 12, we had to pick 2 positive or 2 negative, or if the sum was 11, when the product is negative 12, then we would just switch and say 12 and negative 1. Does that make sense? You have to satisfy both. Now, how does this help? Well, these two numbers are what we're going to use to split up the sum. So here's how it goes. 2p squared. And then notice that negative 11 was split into negative 12 and 1. So we're going to continue with negative 12p plus 1p, which is just p, minus 6. And guess what? This makes it factorable by grouping, which is amazing, don't you think? Now we can go ahead and factor 2p out. That gives us p minus 6. And then plus 1 is a common factor because they don't really have anything else, equals 0. Now you can go ahead and pull the p minus 6 out, and the other factor shows up as 2p plus 1. 2p or not 2p, I wouldn't say that. I shouldn't have said that. Never mind, I take it back. Okay, so now we get two solutions from here. P equals 6 or p equals negative 1/2. But what is p? P is the product. Remember that it is x times y. How is that helpful? Well, maybe we can just plug it in. So from here, xy becomes 6, and from here, xy becomes negative 1/2. Now, let's go back to one of the equations and maybe use the second one. You know why? Because the second equation is actually simpler. 2x plus 3y is equal to 2xy. That was it, right? I hope so. 2x plus 3y is equal, yes, that's right. So now, since we know xy, and we're going to go with both of these values, but this one first, you can go ahead and replace xy with 6. So that gives you 2x plus 3y is equal to 2 times 6, which is 12. Now, along with xy equals 6, now we should be able to solve this system. Now, here's the thing. You can go ahead and turn this into another quadratic equation, or you can try to guess and check. If x and y are both integers, then we'll be lucky and we can solve it easily, right? Trial and error. Maybe x is 3 and y is 2. Let's test it out. 3 and 2. 6 plus 6 equals 12. Beautiful. So from here, we get 3, 2 as a solution. But guess what? Is that the only solution? Probably not, because this should give us, what's it called? Quadratic equation, right? How can we find the other solutions by guess and check though, right? Think about it. Can we switch 3 and 2? I don't think so, because then the sum is not going to be 12. So that's kind of problematic. I think probably the only way to do it is, since I already know one of the values, use substitution. For example, from this equation, you can plug in, like replace y with 6 over x here, and then it should give us 2x plus 3 times y, which is 6 over x, equals 12. And then, of course, you're going to multiply everything by x. 2x squared plus 18 equals 12x, and then divide everything by 2. X squared minus 6x plus 9 equals 0. Guess what? This gives us a single equation. So indeed, there's only one solution that comes from here, which is weird, but I guess that's the fact. X equals 3 is the only possibility, because that's a perfect square. Makes sense? So 3, 2 is gonna be the only ordered pair that comes from the first case then. Now look at the second case. This is the first case. And the second case, of course, we're gonna use that equation again. 2x plus 3y is equal to 2xy. And now we're gonna bring in the xy as negative 1/2. And now we're gonna substitute here. So that's going to give us 2x plus 3y is equal to 2 times negative 1/2, which is negative 1. And then along with this, you can go ahead and solve it. But looks like it's not going to be that easy. I don't think x and y are integers. First of all, they can't both be integers because their product is not an integer. Makes sense? And you can substitute. Substitution is a little painful here. It's totally up to you how you want to do it. Maybe we can try something different. Let's go ahead and isolate y here. Like this, divide everything by 3, and you'll get y. So let's go ahead and replace y with that. And that's going to give us a lot of negatives here, but we can take care of that real quick. This should be negative 1/2. Now we can go to multiply both sides by negative 1, because it's really annoying to have all these negative signs. And let's go with the positive way, okay? Distribute, and then multiply by 3. That gives you 2x squared plus x equals 3/2. Now you can go ahead and multiply everything by 2, and then bring the 3 over, and this should be your other quadratic equation. I think this has two distinct solutions. X equals negative b plus minus the square root of b squared, which is 4, minus 4 times A times C. Of course, that C is going to turn this into a positive, which means guaranteed to have two solutions. That's what happens when A and C are opposite signs, like plus and minus. There's always real solutions, and there are two real solutions. This is going to give us 16 times 3, which is 48, plus 4, 52. So from here, I'm getting something like this. And I think this, we can simplify this. This will be negative 2 plus minus 2 root 13, because 52 is 4 times 13. And from here, I get x equals negative 1 plus minus root 13 all over 4. Now, here's the painful part. You got to find y. And let's just go with, let's say, if I pick this one to be my x value, I need to find the y value. There's two ways to do it. You can go ahead and use this if you want. That seems to be a little easier. I don't know. Or you can use this one. Let's use the other one. xy equals negative 1/2. And now we know that x is equal to root 13 minus 1 over 4. And y is supposed to give us negative 1/2 from here. Now you can go ahead and do this. Multiply by the reciprocal. Y is going to be negative 1/2 multiplied by 4 over root 13 minus 1. And this is when you use the conjugate, root 13 plus 1 here and here. And then that should give us, with these two simplify, there's a negative sign, let's not forget that. These two give us 13 minus 1, which is 12. 2 goes into 12 6 times. And finally, we get y equals negative root 13 plus 1 divided by 6, right? And x equals that. So not very nice solutions, but hopefully they'll satisfy the system. Now, going all the way back here, because remember I was telling you there are two ways to go about it. Instead of using the x method, which is not super bad actually, you can just go ahead and use the quadratic formula. And guess what that's going to give you? That's going to give you the same p-values, 6 and negative 1/2. And you can just proceed as before. Now, let's go ahead and think about if there could be an alternative solution to this system. Instead of just squaring the second equation, could we do something else? I mean, we can try replacing xy with something here, like maybe multiply both sides by 5. But that should give us, let's see. That should give us, what is that going to give us? A weird equation. Anyways, I don't like it. But here's what you can do, though. I think there is an alternative way to do it. And let me know if you can find another way to do it. I'm just going to quickly show you because I know this has been a long video. I hope you don't mind. But here's my idea. I can take one of these equations. Oh, yeah, I can do this. There's actually more than, I think, 2 methods. But this is what I could think of on the spot. We can go ahead and subtract 3y. And then factor out y. That's going to give us this. And then what I can do is get the y by itself. So now this is going to give you y in terms of x. And guess what? You can plug it into the first equation. But that's going to be super painful. You know why? Because you're going to have to square this. That's going to bring some quadratics. And then you're going to multiply by 9, make a common denominator, probably a quartic, which you have to deal with. Anyways, that's painful, but it's just another approach. And yet, my third approach would be the following. You can go ahead and take this equation. And let me show you real quick. This is fun. Oops. So you can go ahead and take the first equation and make it a quadratic and just focus on one variable. And how you can do that, let me show you. You got to pick your variable first. Let's just say we pick y. So you can kind of write it like this, okay? And plus 4x squared minus 12. Now this is a quadratic in y if you just focus on y. Make sense? You can go ahead and use the quadratic formula. That'll allow you to write y in terms of x, and then you can plug it in. But we already got that from the second equation, which was a lot easier. But again, that's just another way to approach it. If you know of any other methods, then just let us know, because this brings us to the end of this video. I don't know where the end of the video is, somewhere here. But as you can see, the solutions are not always that nice. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check SyberMath, and aplusbi, and the shorts channel. And bye-bye.